Hello, in this video we are going to supply the proof to the cross product. In the past few videos I showed you how to calculate the cross product, but I never showed you exactly where it comes from. So uh, the cross product, what it essentially gives us, we've talked about, if you have two vectors, let's say this is vector A and this is vector B, when you take A cross product B, right, what that essentially gives you is the normal vector, we'll call it N, that is both perpendicular to A but also perpendicular to B, right? So that gives you the normal vector, right? So that's what you do when you take the cross product in A and B, right? So we're going to go ahead and derive how we actually get this, what the cross product is when this happens, and it derives from things that we already know. So let's assign first. Let's say that vector A is the vector A1, A2, A3, and then vector B. Let's make vector B similarly B1, B2, and B3, right? And then we're going to call the normal vector, right? We're just going to give it X, Y, and then Z, right? Well, what do we know? We know that if this normal vector, right, is perpendicular to both B and A, then we know that vector B time dot product N, using what we know the dot product, right, if it's perpendicular, it has to be equal to 0. And the same thing happens for vector A, right? Vector A dot product N will also be equal to 0, right? So if we take A dot product N, what are we going to end up with? We're going to end up with A1, A1x plus A2y plus A3z, and that's going to be equal to 0. So that's when we take the cross product of of A and vector N. And then if we take B cross product N, then we're going to get B1x plus B2y plus B3z is also equal to 0. And now what we can do is we can let's eliminate we can eliminate the z variable, right? And I can eliminate the z variable by multiplying. If I want to eliminate the z variable, I'll multiply this equation by B3 and this equation by A3, right? And then what do I get? I'll get A1B3 x, and then I'll get A2 plus A2B3 y plus A3 B3 z, and this will be equal to 0. Now this guy down here, let's extend the page a little bit. Now this guy right up here, if I multiply A3 times this one, I'm going to have A3 B1x plus A3 B2 y plus A3 B3 z is also equal to 0. And then when I go ahead and I subtract these, right, I subtract this whole guy from here, I can see I got like terms here to be this guy minus these guys, right? So I'm going to have I'm going to write it over here, A1B3 minus A3B1. Now that, let's make times x, and then I'm going to have over here plus A2 B3 minus A3 B2, and then that would be y, and that is going to be equal to 0, right? Good, so these two cancel out. Now, what we're going to do real quick is let's solve this equation. Let's take this y over to the other side. So I'm going to have a1b3 minus a3b1 x is equal to a negative y. I'm going to write it this way. a2b3 minus a3b2. And what does this give me, right? Well, if this is so, then I know that, well, for these two to be equal, my x value needs to be equal to this guy, right? So that way I know my x is going to be, for these to be equal, has to be equal to this guy right here, right? So that would be a2b3 minus a3b2, right? And for these to be equal, what would this guy have to be equal to? This guy. The opposite of y would have to be equal to this guy, or I can write y is equal to negative a1b3 minus a3b1. There you go. And then if I wanted to find out what my z coordinate, what my z is going to be, right? I can take this guy right here, and why don't I bring him right down here? And I can plug him right back in to this guy right here. I know what my x is, I know what my y is, and so I can go ahead and figure out what this is going to be. Let me extend the page here again. So to figure out what z is, I could say a1, what's x equal to? a2b3 minus a3b2, and then plus a2, my y is, well, if I make this, since I'm going to plug in a negative here, I'm going to make this a negative a2, right? And then I can plug in a1 b3 minus a3b1, and then plus a3z equals 0. Due to distributive property here, look what I get. a1 a2 b3 minus a1 a3 b2 minus a1 a2 b3 plus a2 a3 b1 plus a3z is equal to 0. Now look what happens right here. I get a1 a2 b3 cancels out with a1 a2 b3, right? So that cancels out. And then I can divide this by ace of 3, and the ace of 3's cancel out, and then I can finally write what my z is equal to. My z, if I add these to the other side, I'm going to have a1 b2 minus, when I take this guy, a2 b3, and there you go. So what does this give us? It gives us, what did we start off with, right? I started off with we wanted to find a cross, let's do a different color here. I wanted to find out a cross product b, right? And I've shown in past videos that we write this I, j, k, and then our a component goes first, a1, a2, a3, just like this, and then I have b1, b2, and b3, good. And then you could see from right above here, my x coordinate would be taking a2, it would be the cross product of, it would be this times this minus this times this, a2 b3 minus a3 b2, right? So this would be a2 b3 minus a3 b2, b2, and that would be my I component, plus, then this one would be minus, right? Since my middle term is, my y coordinate has to be minus, then it's going to be minus it's like putting your hand over the j term, so it's a1b3, a1b3, so a1b3 minus a3b1, j, and then finally my k term is canceling over this, and that would be a1b2 minus a2b1, and that's my j coordinate, and that is the cross product. So what the cross product was is we're doing some type of multiplication, we're finding this normal vector, and we could find out from their components, from what we know of the dot product being, these being perpendicular, they had to be equal to 0, and we're able to derive what the remainder of what the cross product of two vectors is. And now you have an idea of where it comes from. Thanks, guys.